Welcome minions, welcome back to Nick Does Maths. Today we are going to be looking at some vertical circular motion. We've had a look at horizontal recently, we're going to look at vertical circular motion. Again, I've paraphrased a bunch of the question here, you'll get the gist of it. We've got a particle P, mass m, is on a circle, alright? It's attached to a light inextensible string, length L. Okay, so we've got a light inextensible string and it's attached to it, as one does all the time. It is going to be held at rest at A and projected downwards with a speed of root 2 GL meters per second. Okay, so we've got our particle, mass m, on a string. We're going to hold it here horizontally and scoot it down at a speed of root 2 GL meters per second. The tension in the string at when the particle makes an angle theta with the downwards vertical is T. First job, show that T is equal to mg times 3 cos theta plus 2. I reckon we start with that and we'll get back to part B, part C in a second. All right, so what do we know? Well, let's do a bit of annotating, shall we? Boop. We've got mg going down. We've got T going that way. And what I might do is, just for my own sanity, is whack in a theta there. Now, you could be forgiven a circular motion of thinking you want to be using the circular motion equations, but the second we are going vertically, that omega is not constant. And without an omega being constant, we can't really use centripetal forces and things like that, or at least not in the same way. So instead, this becomes a game of energy. Now, there's a couple of ways to think about it. Really depends really on how comfortable you are with negative energies. But just for the sake of it, when I'm going to take the very bottom of the circle as my reference point. All right? I'm not sure if it makes the maths much easier or not, but there you go. Right, so let's look at the start. And we're going to use conservation of energy. So how much energy is there at the start? Well, we've got potential energy. We are a height L above the bottom of the circle, so we've got mgl. And we've got kinetic energy. We've given our particle some kinetic energy. So we end up with half mv squared. So v squared is 2gl. All right? So that is my total energy at the start. Okay, potential energy and kinetic energy. Now then, what do we have here? We are going to use the circular motion equations, but first, I do need to figure out what that V is, all right? I do need to find out what my tangential V is. So we're going to use it, but in terms of V, that tangential V, rather than the omega. So, we've got potential energy here. We've got potential energy. Now, to do that, we need to figure out, let's get a nice green going. We need to figure out what that length there is. We need to figure out what that length there is. Well, let's get another color. There we go. I know that that length there is L cos theta. There's a terrible L. I'm doing my best here. That is bad. That is an L cos theta. So that tells me that that height there is L times 1 minus cos theta. Okay? Do I have enough colors? Let's put some of them down. So, how much kinetic energy do I have? I have potential energy. I have mg times, actually, let's go mgl, 1 minus cos theta, plus half mv squared. And that's going to help me get an expression for v squared. I'm fairly sure I can tidy this up. That is going to give me 2mgl is equal to mgl minus mgl cos theta plus a half mv squared. The m's all go bye-byes. Kabosh, 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 kabosh. And I think that will give me the fact that 1/2 v squared is equal to GL times 1 plus cos theta. Take away a GL from both sides, add on a GL cos theta, and that's where we are. So that gives us one result. We now need to look at that centripetal force. Now we've got an expression for V, we can start looking at our centripetal force. All right. So what force is dragging me in? There's a T, there's an mg cos theta dragging me back out with a little bit of geometry down there. And that is equal to m v squared over L. So let's see what this does. Let's see what this does. T minus mg cos theta. So v squared is twice that, is m times 2 GL 1 plus cos theta over L. So those will cancel out, so that's nice. So T is equal to, I've got the 2mg from there, plus 2mg cos theta, plus another 1, plus 3mg cos theta, which will give me the result that I want. Oop, oop. There we go. Awesome. All right, so far so good. B. At B, the string becomes slack. Find the speed of P at B. Well, so this thing is going to go this way, all the way around. And at some point, probably around there, the string is going to go slack. What does it mean for the string to go slack? T is 0. This is fairly straightforward. So we want T is 0. Well, that tells me that 2 plus 3 cos theta is 0, which tells me that cos theta is minus 2/3. Find the speed of P at B. Well, okay then. We can go back up to this equation here, because this is always true. We've always got this equation up here. It's a good one. We know that cos theta is minus 2/3. So let's put that in. 1 minus 2/3 is a third. So I end up with GL over 3 is 1/2 V squared. So V is square root of 2 GL over 3. Okay. Probably going to have to restart at the top here in a second. But also cos theta is minus 2/3. So cos theta is minus 2/3. We are either, so we're in, basically we're between 90 and 270. So this angle is between, well, 90 and, cos theta is minus 2/3. Little trig circle. Minus 2/3. So we're either somewhere like that or somewhere like that. Okay. Looking at this angle, I would assume that it's going to be somewhere up there is where B is, right? Somewhere up there is where B is. Okay? So somewhere along there, the string becomes slack. Find the greatest height or about above 0 reached by P in the subsequent motion. Actually, let's have that here. So V is root 2 GL over 3. Is that correct? Yes. My little crib notes. So this is square root of 2 GL over 3. Now, what's going to happen in this subsequent motion? The string is slack, basically, which means we are closer to the center than we are to the circle. So we're going to get basically some projectile motion. Essentially, what we've got here is a bit of projectile motion. So, let's sort this one out. I've got that up there. I know cos theta is minus 2/3. So what I'm going to do is I'm probably, because I can't use these equations anymore, right? I can't use these equations anymore because the string is slack. I'm no longer obeying circular motion. So I can't use these equations anyway, but we can still use energy. We can still use energy. Now, the total energy I've got at any given point is 2 mgl. All right, it's 2 mgl. So, C. All right. Now, when I reach my highest point, the main thing is I only have the horizontal component of velocity. I only have the horizontal component of velocity. So, what does that mean? Whatever this velocity here is, I don't know, let's call it VH. And I'm going to call that distance there H. What will I have? Well, my total energy will be mVh squared over 2 plus mgh. And that's what we're going to use, and then we can go from there. So the key thing is finding what is that horizontal component of velocity. Right. So when I'm here, right, when I'm all the way over here, technically, this is my theta. That is my theta right there. That is my theta. All the way up there. So what we probably want is to find out that. Because what we really want, that angle and that angle are the same, and they are both 180 minus. They are 180 minus the angle, my angle theta. They're 180 minus my angle theta. So the point is, cos of my orange theta is going to be 2/3. It is negative the big obtuse, the cos of the big obtuse angle. Check it out, it's just a bit of trick. Now why is that helpful for me? Well, because it's projectile motion, so whatever the horizontal velocity is here will stay the same. So it's telling me that VH is root 2GL over 3 times, and actually, let's keep the colours. The colours are helping. They're helping me. Times cos theta. All right, which is 2/3 square root of 2GL over 3. Right, so let's put that into there. First of all the m's can cancel out. The m's are going to cancel out. That'll be nice. Everyone will have a fun time here. So what do I end up with? 2GL is 4 over 9 times 2GL over 3 times 1/2 plus GH. Well, okay then, the G's cancel out as well, so that's another nice thing. What am I left with? 2L is equal to, anything else cancel out? These 2's cancel out, so I'm left with 4L over 27 plus H. So H is 50L over 27. But we have been asked, but that is the height from the floor. I've taken all of my heights from the floor, so to make sure that all my potential energies were positive. I want the greatest height above 0, which is L upwards. So I'm going to take L away from that. So my answer is 50L over 27 minus L, which is 23L over 27. Woo! That got a little bit messy. The main thing to understand is that once I'm up here, the cos of that orange angle is minus the cos of that big reflex angle. Okay? Check it out maybe with a slightly tighter diagram than that. Okay, I hope that was interesting. Started off relatively innocuous, but there is a bit of mess going on here. And it's whenever you're doing vertical circles, you are combining one-offs of your circular motion. I know I said at the start we're not going to really use it, but we use it in a very different way. But the key one we use is conservation of energy. As soon as we are looking vertically in mechanics, it is way, way easier, more often than not, to go via energy and to use energy. All right? And then we can throw in a little bit of circular motion somewhere in there. Cool. Drop us a comment. Don't forget to like and subscribe. Hit that bell so you don't miss a single one of these. I'm Nick, and I'll see you next time.